Okay, so I've made this video to help you with question 9 from chapters 2 to 5. This is a very standard bifurcation and cobweb structure type problem where you're given a function here, f of x equal to mu times sine of x, and you're asked to do various things. So in both part A and part B, there's a simple fixed point at x equal to 0. You'll do the analysis for that, check the derivative, check that the derivative has a magnitude less than or greater than 1, but there will be other fixed points that arise, and part of the trick is for you to discover the bifurcation picture for those other fixed points. Okay? So to start off with, what you can do is, if you want, you can go to this website that we talked about in class, and you can use that website to help you do the cobweb diagrams. I kind of advise you to do it both on the computer and also by hand. It's important that you do these things by hand because you'll have to eventually do this type of cobweb analysis on the exam. So the first thing you'll do is look at the function mu times sine of x, and you'll try it for a value of mu which is small. Okay, so here mu is equal to 1, and in that case you notice there's only one fixed point, the one at the origin, and you'll do the various things, so check. In this case it does converge into the origin. Okay, don't just do it for this point x0, do it for various points from minus infinity to positive infinity until you get the picture of what's going on. The next thing you want to do is you want to increase for mu larger. And you'll notice that when you do that, depending on how large mu goes, not only will you have the usual fixed point at the origin, but you've also introduced a new one here on the left and on the right, and possibly if mu is still larger, you might introduce further fixed points above there. Okay, so remember that here I've shown there's essentially three types of fixed points that arise. There's the standard one at x equal to 0. They're the two that spawn off from x equal to 0 here on the left and on the right. Okay, and then there's further fixed points that are introduced almost out of thin air as this oscillatory function gets larger and larger. Okay, so basically the question is as follows. What you want to do is, first of all, you derive the fixed points and examine stability by checking the derivative of the function. So this is only for x equal to 0 because you can't solve for the other fixed points in the other cases as easily analytically. Okay, so this is the usual thing where you're going to check the magnitude of the function is less than or greater than 1 depending on what the value of mu is. You verify it with the cobweb diagrams. The next thing you want to do is, you'll notice from what I just explained, is that there are essentially three types of fixed points. There's the standard one near x equal to 0. There's the two that spawn off. There are two that spawn off from x equal to 0 once mu takes a certain value. And then there's finally, they're the ones that are introduced out of thin air. Okay, so those three types, and the ones that are introduced out of thin air, there will be more of them, right? The larger mu goes. For those three types, you want to classify them as either saddle node, transcritical pitchfork, or period doubling. Okay, and you do that by the cobweb analysis. Now you don't have to do this. If you look at the solutions, you'll see that they do so in the solutions. They do classify these fixed points according to their Taylor series coefficients. But you don't have to do this. If you wanted to, what you can do is you can series expand the function. You find the A0, A1, B0, B1, B2, etc. And then you go to your notes and see, depending on what those values are, we found whether those are saddle node, transcritical pitchfork, or period doubling. We proved that those are the bifurcations. Here, the question isn't asking you necessarily to do that. You just have to examine it based on the cobweb diagram. And then finally, you want to make the final cobweb diagram picture. It's going to look something like this. I've kind of blanked it out here, so you get to fill it in yourself. Try to do it yourself. It's going, you can use this picture to inspire you. It will look something like that. And that essentially ends the question. So you'll do this part A for mu times sine x, and then you'll do part B for the hyperbolic sine function.